Alright, we are moving on to rectangles. I sent off to print shop one of these that you'll eventually glue into your notebooks. But it's just a little web so you kind of see what's happening. So we started off with a quadrilateral. It's a quadrilateral. A shape, but what's specific about it? It has 4 sides, right? Okay, now from here we have 2 different kinds. We have either non-parallelograms or parallelogram, and that's what we just kind of quizzed over. The last 3 sections have been on parallelograms, so aka the sides are parallel. Now from here we're going to get even more specific kinds of parallelograms, and the first one is a rectangle. Okay, so knowing that rectangles have all the same properties of a parallelogram because it is a parallelogram, but it has these 2 additional ones. All 4 angles are right angles, so those corner angles are 90 degrees. And now not only do the diagonals bisect each other, but they're congruent at the exact same length. So in our example here, AC is congruent to BD. Today we're just going to use these properties to find missing sides and angles. That's kind of the name of the game today, okay? Okay. Given these measures, let's find the missing ones. So if we want to find QR, what do we know? 10. It's 10, right? Opposite sides are equal. What about SR? 24. Again, opposite sides are equal. Can we find the length of QS for the diagonal? Ooh, I heard it. Pythagorean theorem. What kind of an angle is this?
Right.
A right angle. So I can do 10 squared plus 24 squared will give me my hypotenuse. That's maybe the only thing different today is that we're going to throw in the Pythagorean theorem. Ten squared gives me 100. What's 24 squared?
576.
Perfect, 576. What did we get? 26. Perfect. So now we know the diagonal length is 26. So what's PR? 26, because diagonals are congruent. And QT? Yep, divided by 2, 13. Okay, now let's try find some angles in here. Again, it's a parallelogram, so you have a bunch of alternate interior angles in here. What is also nice, our diagonals bisect each other. So, and since they're congruent, we have isosceles triangles, because these are all the same. So do you guys see that? This is a base angle, and so is this one. So if this is 27, this would be 27. Let's just fill in the angles all in this rectangle, and then we'll go back and fill in what they want us to. I think it's easier this way. Now, can I find this missing piece over here? Because what's this corner angle have to be? 90. So if I take 90 minus 27, what do we get? 63. Again, this is another isosceles triangle. So then this guy's 63. Do I know what this angle is? 27. Alternate interior angles are congruent. Again, here's another isosceles triangle. So this guy's 27, and then 63, 63. Could I find this angle right here? Yep, it's a triangle, right? So if I know two angles, I just have to subtract from 180. What do we get? 54? Perfect. So this guy's 54. Then vertical angles tell me this guy's 54. Now can we find this last angle? How can I find this one? Perfect. Linear pair. 126. Again, it's just a big puzzle. It all fits together. Okay, let's go through and figure out what these are. Angle MJK. What'd you get? MJK. So this big corner angle is 90. MJL. MJL is 63. JLK. JLK is another 63. KML. KML, yep, 27. And MNL, 126. Good work. Okay, the next example, just morphing those two together. You're finding sides and angles. See how far you get before you get stuck. Help your neighbors out. The exact same idea. You're finding missing sides and missing angles. Yep, you will have to use the Pythagorean theorem in here. Or maybe 317. Okay. Bye. Check with the people around you. Maybe we can just ramble off the answers. Okay, what did you get for AC?
42.
42 diagonals are equal. Perfect. EB? 21, half of 42. Perfect. BC? 26, opposite sides are equal. What about AB? 33, Pythagorean theorem. You should have done 42 squared minus 26 squared to get that. Equals x squared. Okay, what about angle ADC? 90. Angle ABD? 38. Angle BCA?
52.
And then angle DEC? 104. Good work. Good work. All right. Our goal here is to find the measure of angle XZW. So this guy right here. 2/2 plant. Jacob.
Oh, 54 x minus 8 is 20.
Is he right? So remember, this angle is the same as this one here by alternate interior angles. And we know that those corner angles add 90. Add like terms. You guys get 13 for x? But then remember we have to plug back in to that expression. $65 minus 8 gives us what?
57.
Thank you, sir. 57. Perfect. All right, one more. Find x. Anyone have a plan? Yeah.
You know that the base angles
Uh-huh.
of the triangles PAG are congruent to the
Yeah.
alternate, or like the outside angle, which is 134.
Yep. She's saying these two are equal. So if I add those two expressions together, it equals 134. That's one way to do it. Okay, let's solve that.
12.
10x plus 14 equals 134. 120. Divide out. What do you guys get for x? We should get 12. That's one way to do it. Did anyone else see a different way, Jacob?
I just took 134 divided by 2, and then set 5x plus 7.
That's how I would have done it. You guys see why that way would work? Because I know that these two angles are equal, right? And they have to equal 134, so I can divide 134 by 2, and that's what this has to equal, right? Just have to split that up evenly. Either way would have worked. Multiple ways to do it. As long as you get 12, it's the right answer. Okay, if you did not finish your quiz, I would like you to maybe do that now, and then everyone else can work on their book assignment. I put little hints on 22 and 24 up on the board so you don't do